This week, we're going to be talking about reviewing fractions as division and dividing a whole number by a unit fraction and a unit fraction by a whole number. So we are going to start with our NF3 standard that says I can write a fraction as a division problem. So the first thing that we are going to review are ways to write a fraction as a division problem. Obviously, you guys know that the 6 is going to be the numerator and the 10 is the denominator part of our fraction. But I can also take this piece and have each of those numbers represent a part in a division problem. If I was going to write this as a division problem, I would need to write the 6 first, the division sign, and then the 10. So I would write that as 6 divided by 10. I could also write it inside of a house, and the way that I like to tell my students to remember how to do this is using the cowboy and the horse theory. The 6 is my cowboy, and the 10 is my horse. When you think about a division house, which one can go inside of the house? Well, I don't know about you, but I wouldn't want a horse going inside. The cowboy goes inside to get a drink of water, so my 6 would go on the inside, and my horse stays outside, which is my 10, to get his drink of water. We've also talked about word problems that involve solving problems like this as well. This word problem says, Jade has 4 kittens. She feeds these kittens a total of 11 ounces of food. Each kitten is given an equal amount of food. And I want to know how much food did each kitten get. So there are a couple things in here that I'm going to look for. I'm going to look for important pieces of information. And I know that her having 4 kittens is an important piece of information. I also have to know how much food that she has. And she has a total of 11 ounces of food. Well, what's she doing with those 11 ounces of food? She's sharing it or giving an equal amount to each kitten. If I give an equal amount of something, what operation am I going to be doing there? I'm going to be dividing. So I have 11 total ounces and I need to give that to 4 kittens. The way that I always have my students remember this is shared over who? So, what is it in the problem that's being shared? She's sharing the 11 ounces of food, so my 11 is going to go on top. Who is the 11 ounces of food going to? Well, it's going to the 4 kittens. And this type of fraction here, 11/4, is an improper fraction. I need to change it and make it into a mixed number. So that means I have to set up a division problem. I know based on my cowboy and my horse theory that my cowboy goes inside, that would be the number 11, and the horse, which is 4, stays on the outside. So I have the problem 11 divided by 4. How many times can 4 go into 11? Well, 4, 8, 12. 12's too big, so it can only go in there 2 times. 2 times 4 I know is 8. 11 minus 8, well, 11 minus 8 is 3. Now I'm able to create a fraction from this division problem. I have my whole number up here, which is 2. 3 is going to be my numerator, and last but not least, my denominator stays the same, which is 4. So they would get 2 3/4 ounces of food. The last problem over here says Nancy bought a pack of cookies for her 3 children to share equally. There were 10 cookies in the pack. How many cookies should each child get? So again, I'm going to start with my important information there. Important information, I need to know that she has 3 children. I need to know that there were 10 cookies. And I need to know that what operation I'm doing here. So I've got to look for words that tell me the operation that I'm going to be doing. In this problem here, the words would be shared equally. That tells me that I'm going to divide. So again, I got to think of shared over who. So What is it that's being shared in this problem? Well, I'm sharing the cookies, so cookies will go on top, which is 10. Who are they going to? Well, they're going to 3 children, so 3 is going to go on the bottom. And again, I have to solve that. That's 10/3. It's improper. I need to make it into a mixed number. Now we're going to jump into dividing a unit fraction by a whole number and a whole number by a unit fraction. And when we talked about these, we talked about modeling. So we're going to quickly review what those models look like before we move into 2 different word problems. For the problem 1/3 divided by 3, I have to model what I start with. And I start with the fraction 1/3. 1/3 is smaller than 1. It is less than 1. So I only need to use one model for this problem. But I have to take this model and break it up into thirds. Now, I have to take my 1/3 here, and I've got to cut it into 3 pieces because that's what I'm dividing it by. So I'm going to cut it over to the side like this, 1, 2, 3. It's important to know that the answer to this problem can be found in the model simply by taking and shading one of those pieces in. So my 1 piece shaded in, 1 represents the numerator, and my denominator is out of the total number of pieces there that I've created. So 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 9 pieces. So my answer to this problem here is 1/9. For this bottom problem here, I have to create the amount of models that I start with. I start with the number 3, so therefore I have to create 3 models. I have to take each of those models and cut them each into thirds. Last but not least, I can solve for my answer simply by counting the number of pieces that I've created. I have a total of 9 pieces, so my answer. Word problems dividing whole numbers and unit fractions are where we see a lot of you guys get really tripped up at, so that's what we're going to focus on next. This word problem says, Josh has 1/4 gallon of orange juice. He wants to split it equally between 3 friends. How much orange juice will each person drink? So again, I've got to look for my important pieces of information. Well, him having 1/4 of a gallon, that's important. I have to know that. I also need to know that he is splitting it equally between 3 friends. And I underlined the word split it equally because that means a specific operation. And that operation's division. And in order to solve this problem, I have to know how to write my equation. So I have to think about shared over who again, but I just think about it written like this. So in my problem, what is Josh wanting to share? Well, Josh is wanting to share his 1/4 of a gallon of orange juice. And he's sharing it with or between 3 friends. I'm only going to include the number 3 in there because it really doesn't say whether it's him and 3 friends or just the 3 friends. So I'm going to leave it as 1/4 divided by 3. If I'm looking to model this equation, I have to model the amount that I start with. I start with 1/4. 1/4 is a proper fraction. It's less than 1, so I only need 1 model. I do have to take that 1 model, though, and I have to break it up into fourths. Then I have to take each of those fourths and I have to break it into 3 pieces. And again, just like we did with the other problem, I can find my answer by shading in one piece. The amount that I shaded would be my numerator, and my denominator will be the whole number of pieces that are in my model, which are 12. So that means that each person would get 1/12 of or they will each drink 1/12 of a gallon of orange juice. The next problem over here talks about cake recipe and making cupcakes. And it says a cake recipe makes 6 cups of batter. It takes 1/3 cup of batter to make 1 cupcake. How many cupcakes can be made if all the batter is used? Well, I have to again think about what I know from the problem. Well, I know that a cake recipe makes 6 cups of batter, and I know that it takes 1/3 cup to make 1 cup. I'm trying to figure out here how many cupcakes can be made if all the batter is used. So I want to use all of the batter. And I can go back into my problem and see how much batter that I have total. Well, I have the 6 cups, so 6 is what I'm starting out with. And I'm trying to find out how many 1/3 are in 6. So for this problem, I would have to do 6 divided by 1/3. In order to model this, I have to model the amount that I start with. So I start with 6, I have to model 6 pieces. In each of those 6 pieces, I've now got to cut them into thirds. And in order to find my answer, all I have to do is just count the number of pieces that I have. So therefore, I counted a total number of 18 pieces. Therefore, I would be able to make 18 cupcakes using all 6 cups of the batter. As always, if you have any questions or any further questions, please make sure that you reach